Hello, and we're going to start the nature of code in Haxe using OpenFL. So the moment we've all been waiting for, we're going to learn about random walks in the Introduction chapter of the nature of code. And yeah, see, there it is, random walks. So I encourage you, please read through this, and so you can get kind of a basic idea of, sort of the theory behind this. But I'm just going to basically work on the code part, and take a look at, what this does. I mean, of course, I'll be talking about this as I code it, but yes, I encourage you to read it. And I think you'll probably understand a lot of the code that's in here anyway. Let's go through it together. Okay. So the first thing that we're going to have to do is we're going to be making this walker class. So this is the actual little thing that's going to move around our stage. So let's make that. Looking at the book here, it's essentially just got an X and Y position, and this should be pretty simple. It's the same as what we did in the last episode, setting up the sort of environment that we're going to work in. So let's do that. Let's make a new class. In the source folder, we'll add class and call it walker, just like that. And it won't extend anything. Maybe it should extend sprite, but for now, let's not worry about that. Maybe we're going straight model view controller stuff, so it's just going to worry about its data. It's not going to worry about displaying itself. And if anyone knows which is better, should the walker be a sprite itself, please let me know, because I am not very knowledgeable in those kinds of things. So, yeah, the walker, it has a position. So, this position should be public for now, just to keep it simple. So we'll put a public variable, and let's call it position. We'll keep it in one thing, and it's going to be a point. I like working with points. What can I say? And when we make a new walker, we're going to take in its position. So X position, which we'll take a float, and Y position, we'll also take a float. Oops, not equals float. Like that. Although I guess while we're at it, let's also set the defaults. We'll just put it at 0 for now. Okay, and when it's made, it's going to set position X equals X position, and position Y equals Y position. Just like that. So when we make it, it's going to take the location that we put it. Good. Next, this just puts it in the center of the screen. So let's put it at the center of our stage when we create it. So first, let's see, should I just do that all right now? Yeah, I guess down here is where they sort of set up their stage and everything. So let's skip down a little bit. So they're going to work with a 640 pixel by 360 pixel stage. So let's copy that, and we do that by going to our project XML and put that here. It's a 630 by 360 or 640 360. 640 360. Although of course this really can be any size. Okay, and then make a new walker. So here, we'll make it private. Private variable. Let's put our walker. We have class walker, and then in our constructor, our walker equals a new walker. And we said we wanted to put it in the center of the stage. So here's how you can center things in OpenFL. So since it's based on Flash, Flash has something called a stage. So what is it? This stage? Yes. And then this is the X. So that's the width. So stage width divided by 2. So basically, this sprite is on a stage, which is essentially the window that it's in. And so you point to that stage that it's on, and this stage has a width. So this stage width divided by 2. And be careful, because there's also a stage.width, like that. That's not the one we want. Be sure to do stage width. I forget the reason why that is the case, but be careful with that. So then for the Y, we'll do this stage height divided by 2. So that'll put it in the center of our stage. So next, let's see. We're going to jump around a little bit. And this is what it does. Let's draw our walker on the stage. So again, I'm not sure if this is necessarily the best way to do it. I'm not sure if we should get into bitmap datas or working with sprites and all that. But we're just going to use the draw function that we made before to draw a little circle. So if you remember, each time we run draw, it's going to clear the screen, and then we have this begin fill and end fill, and it'll put whatever we want there. Okay. So let's say it will draw. No, sorry. This graphics. We're going to draw a circle. And this circle will be at the X and Y position of our walker, position X, our Y, our walker, position Y, and the radius will be, let's say we'll keep it kind of small. We'll say 4 pixels, I think that is, like that. So just to test it out real quick, let's push play, and we should have a little circle in the middle of our stage. And we don't. And why not? Our walker's a new walker. Should be in the middle of the stage. How big is our window here? Yeah, that looks about right. But I don't see no... am I doing something wrong? Let's see. Let's insert... Pretty sure that should be that grayish blue color that we had last time. This graphics draw a circle. Our walker position X. Our walker position Y. 4 pixels. Let's try 16 pixels. And I don't see it. So, let's find out what's going on. So, in our thing here, let's trace our walker, see what it says, and then also, oh no, let's put this in our draw Okay. See what happens. I'm not seeing any traces. So, okay, we're back. um, Strangest thing. So I started a new project, and then the traces were working again, and I copied the code over, and then the traces stopped working. So now I'm back in the original project, and I realized that when I commented out the instantiation of this walker, the traces came back. And I was like, what could be the problem? So I went into the walker class, I swapped out the points for two separate floats, and then, changed the code accordingly. Instead of position X, position Y, it's just X and Y. And then when I came back and changed it down here, made sure everything matched up, then all of a sudden, oh whoops, let's bring back our trace. All of a sudden, our traces started working again. So I'm not sure what it is about points, but for some reason this time it made our traces work weird. If anybody knows what's up with that, please let me know. So let's move on. So we have our circle in the middle of the stage, like this, and let's go on. And this is a random walker. So what is a random walk? Essentially just at each frame it's going to choose a direction, essentially right, left, up, or down and up, essentially. Did I do that right? Let's see, yeah, right, left, down and up. And that is decided by a random thing, a random choice. So let's look at how to get random numbers going. So let's take a look inside of our walker class. So first, we need a thing inside of our walker that generates this random decision. So let's just call this our I think they call it a step, don't they? Let's see. And walker, yeah, they call it a step. So let's keep the same name. So let's give it a we'll make it a public function called step. Doesn't take any arguments, doesn't return anything. And what happens inside of this step? So inside of, yeah, here it is. Inside of step, it makes a choice. It has a choice. It gets a random number, 0, 1, 2, or 3, and then it makes a decision using an if sort of thing, if statement. So let's do that. We're going to make a variable. It's going to be our choice. It's going to be an integer. And we're going to make that equal a random number. So how do we do random numbers in OpenFL? It's fairly easy. It's in a math object. And in here we have random. So yeah, it flashed up there for a second. So if you can see that, it says it returns a pseudo-random number which is greater than or equal to 0 and less than 1. So essentially, also if you continue, they talk about that here. So essentially, with here they have a 4, so it will never be 4, but rather 3.99999 and 0. But I don't think we have that option to just drop a 4 in here. So if this is bringing us a number that's between 0 and 1, how can we make that equal, 4? Essentially, we multiply it by 4. So now it's going to take the 1 and multiply it by 4, so it'll be anywhere between 0 and 4, but never 4. But here's the thing about that is this might come back with something like 2.4, 5, 6, 7, 8, 9, 10, whatever, But we want an integer. So how do we turn this number into an integer? That is fairly easy. What we should do is use another function called math.floor. So basically what math.floor is it'll round down. Whatever number it is, it'll round it down to the nearest integer. So in that case, we'll always get a 0, a 1, a 2, or a 3. Just to test it out, let's trace. No, not just yet. First, let's put in our if statements. So here they have if choice equals 0, do this, else if choice equals 1, do this, else if choice does this, do this, and finally else, do that. But actually, that's a little bit messy, in my opinion. So what we're going to use instead of this sort of else if chain is we're going to use what's called a switch. Not a switch. It's called a switch statement. And I need to look up how switches work real quick. Okay. So what we're going to do is we switch, and then the variable that we're using to switch with, and after that the case of whether it equals this. After the colon, we have our thing that we want it to do. Another case of what value it equals, what we want it to do then. And then we have default, which is like if it doesn't equal any of those, which in this case we won't ever have that happen, but we'll do it just in case. So switch choice. Was that inside brackets? I should really, and I should spell switch correctly. So yeah, switch, and then inside of brackets, then we have case, the value, and then colon. So I'll just write them all out real quick, or one out. So case, the value is 0. We do that. End. And then copy, paste, 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 and then default colon. I guess we'll just do trace. You should not be here. Okay, in the case that it's 1, 2, or 3. So what did they do? In the case that it's 0, x plus plus, x minus minus, y plus plus, y minus minus. So we'll just copy that. X plus plus, x minus minus, oops, x minus minus, y plus plus, y minus minus. And there's actually no case that will have any other option in this. So our walker is pretty much done. So let's go back here and let's call this, let's make an update. So that'll be a private function update. So this is just something that's going to update the information or data in our game or whatever. And in the case of a model view controller thing, this is the model being updated. And if you're curious about model view controller, you should look it up. If you just look up MVC, get out of there, MVC, you can kind of understand what I'm talking about if you don't know already. So what are we going to do in the update? In the update, we're going to do our walker step, just like that. And then we're going to update, and then yeah, draw, and then like that. So I believe we can run it, and we should see our little circly guy jittering around like crazy. Yeah, look at him. Just slowly moving one direction to another. Let's switch it up a little bit. How about plus equals 4. Minus equals 4. Plus equals 4. Minus equals 4. We can get a bit more noticeable of some movement here. Yeah, there we go. Got a little jittery guy all over the screen. So, yeah, there we go. That's what is called a random walk. So, and I guess if we want to have it leave sort of this trail like this, if you remember from when we set this up, if we just take out the clear, and let's make it a little bit smaller. Let's make it just 4 pixels. Although our circle is 4 pixels, is moving 4 pixels, so let's make it 8 so it kind of touches. Although I guess it's 4 radius, so oh well. But yeah, there we go. And now it's gonna like just carve out this little path. And actually, this is a pretty interesting sort of thing to use to sort of dig out caves in a randomly generated dungeon or something, or if you want to make randomly generated, it looks very natural. So yeah, I think usually like caves or like yeah, cliffside, or a map looking down from above, like a lake. This kind of looks like a lake in some reservoir, or in a desert or something. A reservoir in a desert or something like that, or oasis. But yes, yeah, there's it. It appears to have moved off the edge of the universe, so we won't see much more of that. But yes, there's our random walker. So if we continue down, I think it just gives us some other ways to move it around. Right now we're just moving in 4 directions. We could have it move in 8 directions. But it just continues on some of the other things, like it to move it in 8 directions. We'll have a X and Y, and we'll have it bring back a -1 or +1. So in the case that they're both +1, they will move down into the right, and if it's 0 and -1, it'll move up, and like that. So yeah, let's do that. Let's see what happens. So now looking at the random thing, instead of it having choice, let's replace this with var xmove equals random, and there's what 3 directions, right? No. Let's take another look at their code again. Yeah, 3 directions, and then -1. So random times 3, math random, I'm sorry, math.random times 3, math.floor. So we're going to get 0, 1, or 2. But if we minus that, -1, we're going to get 0, -1, which is -1, 2, 1, which minus 1 is 0, and 2, which is minus 1 is 1. So we'll get negative 1, 0, 1, like that. And we'll just copy the same thing over. So copy, paste, we'll do Y move. Yeah, why move when you can stay inside and program all day? Sorry. So yes, so we have the X move and Y move, and then what we're going to do is we'll just take X plus equals X move, Y plus equals Y move. And we're adding because if it's negative, adding a negative is minusing, so it will move in the negative direction, like that. So I think we can just play it, and we probably won't really notice much difference, but there we go. Yeah, it's noodling around like that. Let's do something a little more object-oriented. Let's give it a public var of speed, right? And we'll make it a float, why not? And so this is the speed that it moves, and maybe that's the speed that it moves. Maybe that's the speed it moves per second. Why not? Or actually, for now, let's just do this. So instead of we'll say speed equals that, and then actually when we create it, we'll give it a speed. So in speed, this is just what's coming in, which will be a float equals standard speed. We'll say is 4, and speed equals in speed. And then what we're going to do here is we're getting this negative 1, 0, and 1. So what we're going to do is multiply our speed by that. Or multiply that by our speed, I should say. Like that. And then since we've added a new argument for the constructor there, we're going to have to add it when we create it here. So yeah, we'll just leave it at 4, although that's our default and it'll have the same effect. But let's run it and see what happens. And there it goes. That little guy moving around like that. Okay, so yes, what I'm kind of curious about now, and this is something I haven't tested out, is we made a delta time elapsed time parameter. So I'm curious what happens if we use that instead of just stepping each frame. So let's give it a try. So in our update, let's have step take in the elapsed speed, right? And the elapsed the amount of time elapsed per frame, for the delta time. And actually, let's take out our speed here, or actually, let's make it 400. Why not? And then come back here and let's make our default 400. So step is going to take in a elapsed, which is a float, and what we're going to do is we're going to use this elapsed time to multiply against our movement. So this is kind of interesting because it's going to be changing every frame, so we might not get all of our movement per se, but let's run it and see what happens. I'm kind of curious to see how this will work. Okay, maybe that's a little too fast. Let's bring it in a little bit. Let's do 200. Okay, actually it looks basically the same, except now it's running at a speed that's independent of the frame rate. Although when it moves so randomly like this, we probably don't really notice much of a difference. But yeah, I think technically if we come here and change it to 24 frames per second, it will essentially have the same speed, similar feeling. Although, I guess similar speed, but since there's not as many frames running, there's larger gaps in between. Interesting. Now we know. Maybe we'd have to figure out some way to interpolate the missing spaces in between. But yeah, we'll put it back up to 60. Okay. All right. I think that'll be it for this episode. We'll come back to this and we'll talk about these number distributions. These make for more natural. Right now we're just sort of randomly jumping everywhere, but in reality things aren't completely random like that. They actually tend towards certain numbers. So in the next episode we'll talk about that. That's it for this episode. So I will see you next time. But before we go, I'm going to assign you some homework. As you can see, this circle is not only moving around randomly, but it appears to be changing in size randomly. So I would like you to do two things. First, figure out how to randomize the size of this circle. And if you can figure that out, this particular circle has a radius between 32 and 64. So how did I make this circle stay in between the sizes of 32 and I guess technically 63.9999999, but never actually becoming 64. So yes, that is your quest for the next episode. See if you can figure it out. I think everything that I've taught you, you should be able to do it. There's maybe a few different ways you could do it, but yeah. Good luck. Bye.